Today we discuss on important topics related to group theory. Okay, we also start from the solution of one problem. Okay, we write this problem here. Let H be a subgroup of a group G if X square belongs to this H and for all X belongs to G, X square belongs to H, then H be a normal subgroup of G. We have to prove this one also. Today we discuss on important topics related to group. First we write this problem here. Let H be a subgroup of a group G and X square belongs to H for all X belongs to G. Then H is a normal subgroup of G. We have to prove that. So we write this solution here step by step way. Okay. Now let G belongs to this G group G and H belongs to this capital H. Okay, and consider GHG inverse. Okay, and note that GHG inverse equal to GH whole square. Okay, H inverse G to the power minus 2. We also known about this one easily. That means this one H inverse G to the power minus 2 equal to G to the power minus 2 equal to G inverse. Okay, so not a problem at all. We write it easily in this way. We erase that portion. Then going to further discussion of that. That means here we write now H inverse belongs to H, not a problem at all. Okay, and GH square and G to the power minus 2, this one is belongs to H. Why? GH belongs to G for and G belongs to G. So or G inverse belongs to G. So this one happens square, that means GH whole square and G minus G to the power inverse square belongs to H. Okay. So now what we see, that means this implies that what G inverse belongs to H. Okay, then this implies that G capital H G inverse subset of H. Okay, then what we obtain here, that means hence H is a normal subgroup of G. Okay, not a problem at all. We obtain this one easily. Then next we have to see that we have to show that this G quotient H be commutative. Okay, G quotient H be commutative we have to show now. Then what we do now, that means let this XH and YH belongs to G quotient H. Okay, and then we wish to show that we write so that is our portion. I'm going to further discussion of that. Now we also then discuss this portion. What we have to do? This xh and this yh equal to here yh xh. This implies that xyh equal to yxh. This implies that okay yx whole inverse xy belongs to h. That means if we show this one, then we obviously do this one. G quotient h be commutative. Okay. So now we have to show this portion. Okay. Then we write here. We write what? We write here in this way yx whole inverse xy equal to what? Equal to this x inverse, this y inverse, here xy. Okay. And this one equal to x inverse y inverse whole square, and here y inverse square and y square. We write in this way this one, not a problem at all. We elaborately see this one equal to this one or not. X to the power minus 1 y to the power minus 1 y x y inverse y x y inverse y square equal to what? Equal to this one cancel, this one cancel, then this x inverse cancel, and then x inverse x y inverse, okay, and then x this y in y. Okay, so not a problem at all. So we erase lower portion also. That means this one we write now. Then next what we do, we do step by step. Is then I think all I understand this portion. Now since a square belongs to h for all a belongs to g, okay, it follows that what? It follows that x inverse y inverse, okay, square y x y inverse square y square belongs to h. Okay, then what happened? Then this one, that means y x whole inverse x y belongs to this g. This implies that. Okay, not a problem at all. Sorry, this h. Then thus g quotient h, okay, is commutative. Not a problem at all. G quotient h be commutative. Now we're going to discussion another problem. Okay, that means using this problem we also solve another problem. We write this problem now. First we write this problem, then we're going to discussion of solution of that problem here. That means same, let H be a subgroup of G. Okay, then if index of H in G equal to 2, okay, then H is a normal subgroup of G. Okay, that means index of H in G equal to 2 implies that H is a normal subgroup. Now we have to prove that portion using this problem. Okay, so what we do now, That means we write here solution. Okay, we have to show that what H is a normal subgroup of G. That means this one, x square belongs to H for all x belongs to G. If we show this one, then using this problem we also write this one. Okay, H is a normal subgroup of G. So first we suppose what, there exists x belongs to G. Okay, such that what, such that x square does not belongs to H. Not a problem at all. X square does not belongs to H. Then what happened here? Then mm, then in this way, then x does not belongs to H. Okay, x does not belongs to H, and so H and xh, okay, H and xh are distinct left cosets. Okay, x square does not belongs to H, then x does not belongs to H, and x and xh distinct left coset of H in G. Okay, and again since index of H in G equal to 2, then what happened? Then it follows that, okay, it follows that G quotient H equal to H xh, okay, and hence obviously G equal to H union xh. Okay, this one are that means distinct two left coset, and obviously index of H in G equal to 2, so this one happen. Okay, now x, so x square belongs to G equal to H union xh. Okay, x belongs to G means x square belongs to G. This one happen. So x square, since x square does not belongs to H, so x square belongs to this xh. Okay, not a problem at all. Now we erase our portion and going to further discussion of that. Okay, now here that means x square belongs to xh, so hence x square equal to what, xh for some h belongs to H. Not a problem at all. Okay, then what happened? Then this implies that x equal to H. Okay, and obviously belongs to this H, but this one is contradiction, so hence we also see that x square belongs to H. That means we first write this one, this assumption are wrong, so we obtain this one, x square belongs to H for all x belongs to G. Then by using this problem, what we obtain? By using this problem, we obtain also this one. That means H be a normal subgroup of G. Okay. Then H be a normal subgroup of G. Not a problem at all. So we do this problem easily. I think all are understand this clearly and properly. And obviously, if you follow my channel, see this video regularly, and obviously click on like option. And if you interested on these topics, please click on like options and comment something about that. So please subscribe my channel. I obviously request you follow my channel and see this video regularly. So today I stop here. Okay.